All right, so like I just said, 12.4, Law of Cosines. This is from geometry. I know you guys may not remember it. That's okay, but I just want you to know you've kind of seen it before. This is what we use when we don't have a right triangle. If we have a right triangle, we would use SOHCAHTOA, 30, 60, 90, 45, 45, 90, something like that. So the first part of this, though, is the area of a triangle. Before today, what did you say the area of a triangle was? What was the formula for the area of any triangle? 1/2 base times height, right? That's still totally fine. The problem is sometimes they don't give you enough information to do 1/2 base times height. Sometimes they don't give you the base or the height, right? So if this is a question where they gave me the sides, maybe, I couldn't necessarily do 1/2 base times height, or I would have a lot of work to get there, okay? So this is just another option for when 1/2 base times height doesn't work or it's not quick and easy, all right? So again, this looks like it's 3 different formulas, but it's really not. It's essentially the same formula, just different pieces were given to you. So, if you guys forgot, the capital letters stand for the angles, and the lowercase letters are for the sides. So if you look here, capital A is across from little side A. Capital angle B is across from little side B. Capital angle C is across from little side C. So, with this, let's just look at the first one. The area of this triangle, you can say 1/2 side B times side C, so B and C, times sine of the angle in between them. That's called an included angle. Do you guys see how angle A is in between C and B? Okay. Same thing, it just depends on what they gave me. Let's say that question they gave me angle A, and I was missing side B or something like that. So, same thing, just different options. So this time, I would say 1/2 times side A, side C, I would have to use the included angle between them. It would be sine of angle B. So without looking, if I said 1/2 A times B, it would be sine of angle C. Okay? So it just depends on what they give you, which one you would use. So I don't memorize these 3 separate ones, as in like AC, sine of whatever. I memorize side times sine of the included angle between them. That's kind of how I look at it. Okay? You can use this if you know the lengths of 2 sides and the measure of the included angle. If you don't, you'll have to do something else. Okay? So when we get there, I'll show you what I'm saying. The law of sines is, again, I don't memorize necessarily all 3 of these this way. I memorize the sine of an angle over its side equals the sine of another angle over its side. You only pick 2 of them. The reason they have 3 is to let you know that you can use any of the 3, but you'll use 2 at a time. It'll be a fraction equal to a fraction, and then you'll probably cross multiply and divide. So, again, angle over its side, angle over its side. To use this, you have to have angle, angle, side. I'll refresh your memory on what that looks like, or angle, side, angle. So, for example, angle, angle, side. You don't have to draw this down if you don't want to. Maybe just kind of watch me first. Angle, angle, side means I know, like, these 2 angles. I'm totally making them up, by the way. And then a non-included side. Do you see how it's 2 angles and a non-included side? If I had this side, that would be angle, side, angle. That's not the same thing, okay? For angle, side, angle, it's what I just showed you. Angle, included side, angle. Is that okay? Okay. Something you probably did not talk about much in geometry, if at all, I don't know, is the ambiguous case. So it's kind of like an extraneous solution type question. If you have SSA, forgive me, you know I never swear in here, but SSA to help you remember ass, okay? That helps you remember, all right? But I call it SSA. If you have ass, okay, then you could have 0, 1, or 2 triangles. That's probably the first time you've heard that before. So you've only ever seen 1 triangle. You've never seen a triangle make 2 triangles before, I don't think. So I wish we had time to do this activity where we do like toothpicks and I show you that it doesn't work. Something you probably forgot from geometry is for something to form a triangle, the 2 smaller sides have to add up to be greater than the 3rd side. So for example, we've had a 3, 4, 5 triangle before, right? Again, don't draw this or write it down, just listen. We've had a 3, 4, 5 triangle. We talked about that just the other day, so we knew stuff about it. But the reason it forms a triangle is because 3 plus 4 is bigger than 5. If that doesn't happen, you literally can't make a triangle. So if we had the toothpicks and we could do it, if I had a 1, 4, 5, like 1 inch side, 4 inch side, 5 inch side, if I had a 1, 4 triangle and I gave you those toothpicks that were 1 inch, 4 inches, 5 inches, or whatever, you would see that like the 2 sides, you can always make 2 sides of it, but that 3rd side won't reach the corner. Like you can try and fidget with it all you want. It's not going to make a triangle. They don't connect. Does that make sense? So that's when you have 0 triangles. To have 2 triangles is when you have 2 choices. So like, again, it still has to follow this rule, but you could either make a triangle that's like skinny, or you can make one that's obtuse. So sometimes you have 2 triangles as an option. But that only happens if we have as, okay? So again, that would look angle side side. That would look like here and here and here. That's side side angle. 2 sides and a non-included angle, okay? Not here. That's side angle side. Do you guys get the difference? When we get there, I'll refresh your memory, okay? So, the safest bet is to use the law of cosines first. So, law of cosines from 12.5, but we aren't doing that, so you don't remember that. From geometry, we did law of cosines, but that's okay. We don't have to worry about that today. So, here's how we do it. Steps to solve it. Step 1, set up the law of sines and solve for an angle. Then you have to take 180 minus that angle, see what you get. If there's a possible second angle in a second triangle, I'll explain this in a second. Then you take 180 from that minus the original angle in the triangle. So option 1, if you have a negative, then there's no second triangle. Option 2, if you have an answer, a second triangle exists. That's not going to make sense till I do one. So that'll help us later. Don't worry about it right now. If they say solve a triangle, they mean find all the unknown side lengths and angle measures of a triangle. So when they say solve the triangle, typically they gave you 3 pieces. They want the other 3 that are missing. So they don't just want angle A, they want like all 3 things they didn't already give you. Okay? So that's just a bunch of information. And then we're going to do some. So number 1, example 1, find the area of triangle ABC to the nearest tenth. So do you guys see that I have side, angle, side? Do you see that? So if I go back to the front, 2 sides and the included angle, that's the same as side, angle, side. So because I have that, I can use these 3 are the same formula. You just take 1/2 times the 2 sides times the sine of the included angle. So I'm going to say the area equals 1/2 times the 2 sides times the sine of the included angle. What is that? 104? 104. And you literally just plug it in. Do you guys understand how I'm using that formula? I didn't try to figure out what A, B, or C was. That's not really the point. I don't care, right? And nearest tenth. What do we get? 34.9. And then that would be centimeters squared. So I understand that 1/2 base times height is a formula that exists, but on this question, it would not be quick or easy or even possible. I don't know, I'd have to look at it again. But if it were possible, it's not as quick and easy as this one, right? All right, example 2, solve triangle ABC. That means find all the missing pieces, round to the nearest tenth if necessary. So they gave me angle C, they gave me angle B. I'm missing angle A, so I'm going to be like, measure of angle A is, I don't know, I'll find it later. I'm missing side A and I'm missing side B. So again, they gave me 3 pieces, I'm looking for the other 3. Which one of those would be the quickest to find? Angle A, or side B? Angle A is very quick and easy to find. How do I find angle A? Right. The 3 angles of a triangle add up to 180. So I'm going to take 180 minus 80 minus the 45. Or someone said add them up, subtract from 180. That's the same thing, right? So take 180 minus 80 minus the 45. And what do we end up with there? 55 degrees. Okay? So that was easy. Everybody could have done that without me, right? From here, I have angle, angle, side. Do you guys understand? I have angle, angle, side. Okay? So if I go back to the front, I'm not doing area, so I don't care about that. I have angle, angle, side, so I'm going to use the law of sines. I don't honestly memorize what to use when. I just try it, and if I don't have enough information to use the law of sines, I know it must have been something else. But since we haven't talked about the law of cosines yet, it's obviously going to be the law of sines anyway. So the law of sines just says take the sine of an angle over its side equals the sine of an angle over its side. Okay? We do not have SSA, so I don't have to worry about the extra weirdo stuff. I'm just going to do the problem. Okay? Okay, so I'm out of room, I'm going to go up here. I'm going to take the sine of some angle. I'm going to pick the 45 over its side. What's its side? What's the side across from angle B? Side B. You guys see what I'm saying? Okay. Then I have to pick another angle. I try not to use anything I came up with on my own. Even though I'm pretty confident that angle A was right, I try not to use it because what if my finger slipped and I'm off by like a degree, right? Then I'm automatically getting the whole thing wrong. So I try to use what they gave me instead. So I'm going to say it's equal to the sine of 80 over its side. What's the side that is in relation to the 80? The 3. Do you guys get that? Sine, cosine, tangent always goes with angles, by the way. So that's how I know where that went. Okay? So we're going to cross multiply and divide. Use your calculator. You're going to take the sine of 45 times 3. You're going to hit the equal sign. And then divide by the sine of 80. You're going to hit the equal sign. And we're going to round to the nearest tenth. I'm getting 2.2. Good. So now all I'm missing is side A. I have to do this again. It's not an option. So you can't use Pythagorean theorem. I don't have a right triangle. You can't use SOHCAHTOA. I understand I just used sine, but in a different way. You cannot use SOHCAHTOA because it's not a right triangle again, right? So the whole point of the law of sines is because it's not a right triangle, I had to do something else. So I'm going to use what I used before. I'm still going to use that sine of 80 over 3. That's still true, okay? But this time, if I'm finding side A, I'm going to take the sine of what? I don't have a choice this time. Angle A, we said was 55. Do you guys see what I'm saying? Okay. So again, you're going to take this times this, hit the equals, divided by this. So you're taking the sine of 55 times 3, hit the equals, divided by sine of 80. Be really careful. If you're going to take sine of 55 times 3, make sure you end the parentheses on the 55. If you know you're not very good at that, you might want to just do the 3 first instead, and then hit the equal sign. And what do we get to the nearest tenth for that one? Very good. 2.5. They said solve the triangle. We did. Okay, so on that one, for you, Andrew, I would hit the 55, then the sign, times 3, hit the equal sign. Yeah. Now divide by the 80 sign for your calculator. You got it? Okay. There are other ways to do it. Andrew, you could have taken 3 times 55 sign, hit the equals. Like, that should have been fine, too. So I'm not quite sure what happened, but... All right. Determine whether each triangle has no solution, 1 solution, or 2 solutions. Then solve the triangle, round the side lengths to the nearest tenth, and the angle measures to the nearest degree. So this is probably going to be that ambiguous case option, right? If they said that, it's probably what it is. So I'm going to go ahead and draw my triangle. They said triangle RST. Obviously, it doesn't matter where you put the R, the S, or the T, but since we're doing it together, let's do them all the same. I have the R on top, the S on the right, the T on the left. Okay? So I'm going to fill in what I know. They said angle R is 105. They said side R, which is right across from it, is 9. Side S, little s, across from angle S is 6. Is everybody okay with what I just did? Right? So we're missing 3 pieces. I'll get to that in just a second. Again, one more time. I put the R here, the S here, the T here. It doesn't matter. You guys could have put the R here, the S here. Like, it doesn't matter. But since we're doing it together, let's just do it together. So this is SSA. Do you guys see there's 2 sides and a non-included angle? So this is the one where I have to be really careful and check for ambiguous case, but they kind of told us that anyway. Okay?
Why is it not like SAS?
SAS would be, let me show you. SAS, literally the A is in between the S's. That's called an included angle. If the angle were here, that would be SAS. So what we have is 2 sides and a non-included angle. 2 sides not included. The angle they gave me could have also been this one, but not that one. Okay? Okay, so I know that I'm missing angle S, angle T, and side T. I'm missing angle S, angle T, and side T. This one isn't as easy. I'm not able to find an angle first by subtracting from 180, right? I'm missing too much stuff. So the first thing I do no matter what is I try the law of sines, right? So I'm going to say sine of 105 over its side. What's the side that corresponds to the 105? Equals something over something. I can't be missing two things. I can only be missing one thing. So what do you think? What else do we have that we haven't used? The 6. Is that a side or an angle? It's a side. So it goes here. What's the angle that corresponds to it? Yeah, good. Do you guys get how to fill in that formula there? Okay. So we haven't figured out if there's an ambiguous case yet or not. You just do it like we did all the other questions so far. So you're going to take this times this, you're going to hit the equals, you're going to divide by this, you're going to hit the equals, and you're like, that looks weird, right? So everybody do that. Take sine of 105 times 6, or vice versa, 6 times sine of 105, hit the equals, divide by 9, hit the equals. What do we get? Point something weird, I'm guessing. 0.64, right? That doesn't even make sense. Not that that's not possible, but it doesn't make sense. The reason we're not done yet is because this isn't alone yet. It says sine of what we want. So it's not alone yet like those other questions were. Does that make sense to you? So how do I undo sine? Second sine, sine to the -1, right? So you don't have to write anything down. I want everybody to push your second sine button, except for Andrew. Hold on. Everybody push your second sine. If you did, it's okay. I think I can fix it. Push your second sine button, and the answer went away. And you're like, oh my gosh, the answer went away, right? To get the answer back, you guys push the second negative, I think. Above that is A and S. Yeah? And that'll say, hey, do the second sine of the answer I just had in my calculator, and hit the equal sign. And you should get 40. Is that what you guys got? Because it said nearest degree. Yours is fine. Yeah, yours, you don't have to hit anything. You just hit second sign and you got it right. Okay. So everybody got 40. Okay, so what we need to do is, that means there's obviously at least one triangle. So we're going to go ahead and just finish this triangle like all the other questions. The question after that is going to be, is there possibly two triangles? Does that make sense to you? Okay, so it's obviously not 0 triangles because this is working. I don't know if it's 2 yet. I'll get to that in a second. I'm just going to finish it like I would anyway. So if I have angle S is 40, I could find angle T really easily, right? I'm going to take 180 minus 105 minus 40, and what do I get for that? 35 degrees. Very good. So now all I'm missing is side T, right? So whatever you've already used is still going to be usable. Like that sine 105 over 9, I don't really have to think about it. I'm just going to use it again, okay? So I'm going to go over here. I'll erase this later. Sine of 105 over 9 equals, this time I'm missing side T, so I need angle T. Angle T was 35. Do you guys get that? Okay. So this time when you cross multiply and divide, your answer is your answer because T is alone. Right? Tell me what you get when you get it. So these 3 answers are for sure good. The question is, do I possibly have a second triangle? So I'm going to jump back to the front and show you what it said again, and then we'll do it. So to see if you have a second triangle, we take 180 minus the angle we got the first time. So really I like to do it in the beginning before I finish that triangle, but I also kind of wanted you to know it's the same thing. So what we need to do to see if there's a possible second triangle, I'm just going to write all over everything and I'll come back later. I would even write this down, possible second triangle, okay? So if there's a possible second triangle, I take 180 minus the first angle I got. So 180 minus 40 is what? 140. Good. And I know you guys know 140, but I would for myself tell myself how I got there. I took 180 minus that first angle I got, and it's 140. Okay? So here's how you see if you can have a second triangle. I'm going to take, that 105 is still part of the triangle. Okay? If I have a second triangle, 140 is part of it, right? So I would be like, is that possible? What's 180 minus the 105 that they already told me minus the 140 that I just said? What happens when I do that? You get a negative. You get negative what? Negative 65. So is a second triangle possible? No, because the two angles I had were already over 180, so there literally wasn't space for a third angle. Does that make sense to you? So no second triangle. This was just a one triangle. Just like the question before it, we just didn't have to check for anything extra. So this ended up not being different in any way, but we had to check to see if it would have been. Am I making sense? Once we get one, I think you'll see what I'm saying, okay? So we did it just like normal. We had to check to see if a second triangle was possible. The way you do that is you take 180 minus the first angle, and you see if there's room for another triangle, and there wasn't. So move on, okay? Does anybody need this before I get rid of all that? All right, I'm going to erase this. So we're going to draw another triangle. You should have plenty of room. I just didn't. Okay. Oh, darn it. All right, it's fine. Okay, so triangle ABC, I'm going to go over here again so I have plenty of room. Again, it doesn't matter where you put the A, the B, or the C, but I would do it where I'm doing it just so we're all consistent, okay? So I'm going to label what I know. Angle A is 54 degrees, so that goes here. Side A is 6, so that goes across from angle A. Side B is 8, so that goes across from angle B. Does everybody understand that side, non-included angle? So even if the directions hadn't already hinted to me that I need to check for the ambiguous case, I would know, oh crap, that's SSA. I need to see if there's more to this later, right? So I'm going to start it just like I start anything else. I'm going to say sine of 54 sine of 54 over 6 equals, what's the only other piece of information I have? The 8. Is that an angle or a side? That's a side, so it's going to go in the denominator. So then I'd have to take the sine of angle what? B. Very good. Does everybody understand that's the only way I could have started this problem, right? So you're going to cross multiply and divide. Don't forget your second sign. And tell me what happens. You should get an error. Everybody do it. Take your time. If you don't get error, tell me. If you get an error and you're confident you did it right, that means no triangle existed. It means that if I were to find the sides, if I were to be able to find them, the two smaller sides did not add up to be bigger than the third side. I was not physically able to make a triangle out of this. Is that okay? The error ones are easy. If you get error, no triangle exists, you're done, move on. Okay? All right, last question. Again, we're going to draw triangle ABC. I put the A up top, I put the B here and the C here. Angle A is 35 degrees, that goes here. Side A is 17 over here, B is 20. So again, side angle, right? I start it like I start anything. Why don't you guys try to set up the original equation that I would start with? You guys try to do sine of something over something. See if you can do that. And then wait for me. So we would start with, I would say sine of 35 over 17 equals sine of what? B over 20. Do you guys get that by now without my help? Okay. So go ahead and cross multiply and divide. Take your second sign at the end, right? If you really wanted to, you could technically do second sign of the whole thing, but I just think that's kind of a lot of stuff. So I cross multiply and divide, and I do second sign at the end. So we're missing angle B, angle C, and side C. And what do you guys get for angle B? 42 degrees. Okay? Is everybody okay with that? Do you want to go ahead and finish this triangle the way it is, or do you want to see if there's a second one and then come back? What do you guys want to do? Let's maybe just finish it. Let's just finish the triangle the way it is. So if angle B is 42 degrees, angle C is whatever 180 minus 35 minus 42 is. And what do we get for that? That's easy, right? 103? So I'm now going to find side C. So I'm going to use my sine of 35 over 17 again. That's still true. And then sine of angle C over side C. Cross multiply and divide, there's nothing extra to do because C is technically alone. And what do we get?
28.9.
Very good, 28.9, okay? Angles to the nearest whole, sides to the nearest tenth. So that part's easy, right? There's at least one triangle, that's obvious. Now we have to see if there's a second triangle. So if I go back to the front, we did that. Take 180 minus the first angle we got, right? So 180 minus the first angle we got gives me what? So if there's a second triangle, I'm going to call it, bless you, angle B2. If this works, it's going to be 138. If it works, I don't know. I have to see if there's enough left, right? So the original angle was 35. That's still true. If a second triangle exists, my second angle is 138. Is there room for a third angle? So take 180 minus the 35 minus the 138. And what do we get? Do we get a negative or a positive? Positive, what do we get? So that means a second triangle existed. Does that make sense? So the way you do it is you take 180 minus the first one, we got 138, and then you're like, okay, here's my whole new question. My whole new question is this guy, and then I don't know. So you take 180 minus the 35 minus the 138, and we're left with 7. That means a second triangle existed. So that means I can finish the problem and find the second side C. Okay? So if this is my new triangle with this angle, and this angle, right? I can still set up my formula. So if I'm using my second triangle and I'm looking for side C, the sine of 35 over its side is still true. That's still part of my original triangle, right? But if I want side C, I need to use my second triangle's angle C. What's my second triangle's angle C? Good. So it's the same thing. It's just kind of like a part A and a part B, right? So cross multiply and divide. Nearest tenth. And what do we get? Good. So we had 2 triangles, right? Triangle 1, triangle 2. Is that okay? Okay. Did I lose anybody anywhere? Anybody need me to go back to anything?